Hey there, I'm one of the technicians working on NASA's Orion spacecraft. Every day, we help build the systems that will carry humans deeper into space than ever before. Come with me, Sawyer. I'll show you exactly how NASA builds the Orion spacecraft from start to finish.
Inside NASA's enormous assembly facility, the Orion spacecraft begins its journey. Large metallic capsule sections arrive for processing, and teams prepare the materials that will form the core of this deep space vehicle. Aluminum alloy sheets are inspected and cut with precision lasers, shaping the curved panels that protect the crew. Robotic arms bend and weld each piece with microscopic accuracy, building the pressure vessel that must survive extreme forces. As the structure takes shape, technicians scan every weld and joint, ensuring the capsule meets NASA's highest standards.
Reading stable at 0.05.
Zooming in on Sector 4, looks good.
Layers of insulation are added, and the Orion shell rotates on massive platforms while robotic tools smooth each surface.
This reading is slightly off nominal. Can you verify with the optical scanner?
Confirmed. The variance is acceptable according to the updated specs.
Inside the capsule, the next phase of construction begins. Technicians install strong titanium supports that form the internal skeleton of Orion. Every bracket, beam, and fastener must line up with microscopic precision. In the avionics section, wiring harnesses and control modules are mounted piece by piece. Robotic arms route dense bundles of cables through narrow channels, connecting life support systems, computers, and navigation hardware. These systems will keep astronauts alive and guide the spacecraft millions of kilometers from Earth. Meanwhile, NASA teams prepare the spacecraft's powerful thermal protection. In a specialized area, the massive heat shield is formed, its surface covered in thousands of ablative tiles designed to survive re-entry temperatures hotter than molten lava. Engineers scan each tile with lasers, checking durability before attaching the shield to the base of Orion. Every step is recorded, measured, and tested, because for a spacecraft, even the smallest detail can decide the success of a mission.
Initiating sequence B, pressure ramping up.
Levels stable, holding at 300 GPa. Test passed, logging the results.
Now the spacecraft begins to take its full shape. With the heat shield secured, engineers connect the capsule's internal systems to the service module below. Robotic torque tools lock high-strength bolts into place, sealing one of the most critical structural joints. Inside, avionics modules are powered on and connected to Orion's heartbeat, its power distribution panel.
Check the alignment on section Gamma 12.
Looks stable from here, but let's run the diagnostic again.
In the propulsion area, large fuel tanks and engine mounts are assembled. Robotic arms install maneuvering thrusters that will steer Orion through space with incredible precision.
Line 7. It seems low.
It's within tolerance, but we should monitor the pressure differential here.
Nearby, the spacecraft's solar arrays come to life for the first time. Technicians unfold and test each panel, ensuring they deploy cleanly in space. Automated machines attach solar cells to their frames with exact alignment so the array can deliver stable power during the mission.
Reading confirmed. Reading confirmed. We are within acceptable limits.
Look at the reading on channel 7 right here.
I see it. It's within the predicted tolerance margin.
As testing is completed, Orion moves into one of the most important phases, joining the crew module with the service module.
Orion alignment looks
Technicians guide both sections into place while massive hydraulic arms stabilize the spacecraft. Robotic locks engage, securing the structure with incredible precision. Next, the integrated spacecraft undergoes electromagnetic testing. Giant coils surround Orion and scan its electronics to ensure nothing will malfunction during spaceflight. Inside the clean room, engineers install the parachute housing, carefully folding the heavy cords and attaching the massive parachute assemblies that will slow the capsule during its return to Earth.
Cycle test complete.
The hatch
All
mechanism
parameters
is
nominal.
tested repeatedly,
Confirmed.
opening and closing
Hatch
through
seal is
hundreds of
secure.
cycles to guarantee flawless performance. In the life support chamber, engineers monitor airflow, pressure, and oxygen systems, ensuring Orion can support astronauts for long-duration missions far beyond Earth. Radiation shielding tests follow. Special layered materials are examined under intense scanning instruments to verify they can protect the crew from deep space radiation. Finally, robotic arms apply protective coatings across Orion's exterior, sealing the spacecraft with a smooth, durable finish.
Okay, gently
Technicians
align with
install
calibration
star
marks.
tracking cameras and precision optical sensors that help Orion determine its position by reading
Data
constellations.
stream looks nominal.
These systems are
across all
calibrated
channels.
carefully,
Good.
using rotating light patterns that simulate the stars Orion will see in deep space. Next, engineers unfold and test the spacecraft's communication antennas. Each antenna must
Look here.
deploy flawlessly
The error
and
rate
transmit
dropped
signals
significantly
across
after the
hundreds of
last
thousands of kilometers.
Confirmed. The isolation seems
Inside the
stable now.
RF chamber, powerful equipment
minor
checks for
fluctuation on the
interference,
power conduit.
ensuring Orion can
Rerouting
maintain
auxiliary
uninterrupted
power
contact with Earth.
The navigation link is
Once
stable.
communications are verified, Orion moves into full system integration. Dozens of technicians monitor computer screens as the spacecraft's power, navigation, propulsion, and life support systems are activated together for the first time. Nearby, robotic arms test Orion's docking adapters, mechanical clamps that allow the spacecraft to connect with other vehicles during future missions. Every latch, hinge, and mechanism must respond perfectly. Finally, Orion is secured onto a reinforced testing stand, where massive shock simulations and launch-level vibrations are applied.
Temperature is rising too fast. We have to shut it down.
After passing thermal and vacuum trials, Orion emerges from the test chamber covered in frost. As the spacecraft warms,
Look at the
engineers
thermal readout.
inspect
It's
every
climbing
temperature
past
sensor
critical.
and stress marker
I'm
to
getting
confirm the
corresponding
structure
stress
performed
fractures on the
exactly as
wireframe.
expected. From here, Orion travels across the factory on an automated transport platform. Inside the integration hall, technicians align and calibrate the spacecraft's flight computers, the systems that control navigation, propulsion, and stability during the mission. Next, the spacecraft's control screens come alive, displaying simulated mission data. In the assembly zone, robotic arms attach the launch adapter ring.
Confirming synchronization.
This massive structure will secure
All locks
Orion to the
secure.
rocket that carries it into space.
Check the readout on
Once
on
installed,
channel 3,
NASA
spiking
teams
slightly.
run final power system
It's
checks
within
on the
tolerance
service
parameters.
module,
We are green
verifying
across
that
the
the
board.
solar arrays and power units can supply energy throughout the mission. Finally, the spacecraft is prepared for transport. Hydraulic clamps lock it into place as technicians wrap Orion in protective thermal blankets. The spacecraft is then rolled toward the departure hangar, ready for its journey to the launch integration tower. As Orion departs the assembly building, hydraulic lifts raise the spacecraft onto a massive multi-wheel transport vehicle. Engineers secure the structure while bright sunlight fills the hangar. Outside, a slow-moving convoy begins its journey across NASA's sprawling facility. Escort vehicles guide the transport, while teams monitor stabilization data from control displays inside support vans. The spacecraft soon approaches the towering integration building where the Space Launch System components are prepared. Inside this tall chamber, technicians attach lifting brackets and prepare Orion for vertical hoisting. The overhead crane lifts the spacecraft high into the air, guiding it toward the adapter stage with laser precision alignment. Red alignment grids scan across the metallic surfaces as teams monitor the descent carefully.
Standing by for contact
At last,
confirmation.
the Orion spacecraft is lowered onto the rocket's adapter stage. Engineers from multiple platforms oversee the process, ensuring the connection is perfectly aligned. Once secured, stabilization clamps lock Orion onto the structure. In the towering integration chamber, the spacecraft stands tall, ready for the next phase of assembly.
Connection sequence.
As Orion reaches the upper levels of the integration tower, technicians connect it to the SLS upper stage with high-strength cables and structural bolts. Robotic tools secure each attachment point, ensuring the spacecraft stays locked in place during the violent forces of launch.
Rerunning the
Engineers then run a full diagnostic check, confirming that every navigation, communication, and power system is working exactly as expected. Next comes a critical step, enclosing Orion inside its aerodynamic payload fairing. Two enormous white fairing halves close around the capsule, forming the protective shell that shields it during ascent. Inspection teams verify the separation systems and alignment points before the entire fairing assembly is lifted again. Finally, cranes lower the enclosed spacecraft onto the top of the SLS rocket. Mechanical latches secure it, and technicians perform their final walk around as the fully stacked vehicle stands tall inside the integration tower.
I'm getting a high reading right here on the TPS.
Let me see that. Could be an air bubble.
Copy that. Logging the anomaly at 400 feet.
As the final checks are completed, the fully assembled SLS rocket and Orion spacecraft are prepared for rollout. Massive clamps release the vehicle, and the crawler transporter moves into position beneath the launch platform. Slowly, the rocket is lowered onto the crawler's huge steel treads, and the journey to the launch pad begins. Engineers follow alongside, monitoring tilt, stability, and transport systems. The giant vehicle rolls down NASA's crawlerway, illuminated by bright floodlights as it approaches the launch complex. At the pad, hydraulic stabilizers lock the rocket into place for final preparations. Technicians connect cooling lines, power cables, and access platforms, performing the last round of inspections. By nightfall, the Orion spacecraft stands ready at the top of the SLS rocket, waiting patiently for its upcoming mission.
Flight, this is pad 3. All primary systems showing green.
Umbilical secure and holding stable pressure.
Copy that. We are RTB.